नमस्कार दोस्तों, वेलकम टू गेट वाला। मैं हूं सतीश कुमार दुरिशेट्टी, फैकल्टी ऑफ मेजरमेंट्स। मैं बार्क सीरीज को स्वागत कर रहा हूं। बार्क एग्जाम में मेजरमेंट्स में क्या क्या क्वेश्चंस आ सकता है, बार्क का सिलेबस जो भी है लगभग वो भी गेट का सिलेबस की तरफ से हो जाएगा। भाभा एटॉमिक रिसर्च सेंटर में इलेक्ट्रिकल इंजीनियर्स के लिए, इंस्ट्रूमेंटेशन इंजीनियर्स के लिए भी मेजरमेंट सब्जेक्ट होगा। सो रिटन टेस्ट में क्या क्या आ सकता है, क्या लिखना है, सो व्हाट आर द कॉन्सेप्ट विल डिस्कस बिफोर गोइंग फॉर द कंटेंट। ओके, बिफोर गोइंग फॉर द क्वेश्चंस, फर्स्ट ऑफ ऑल लेट मी डिस्कस the syllabus overview. Let me syllabus overview करने दो. So if you see the measurement syllabus with respect to gate exam I'm telling, and gate and IES also will discuss. So if you see the measurement syllabus, in this we are having three parts. We are having three parts: electrical measurements, electronic measurements, and non-electrical measurements majorly. So first comes the electrical measurements, next comes the electronic measurements, next comes the non-electrical measurements मेरे दोस्तों. Okay, so here comes the first. Comes electrical measurements. One second. Yeah, if you see the content, so here comes the electrical measurements, electronic measurements, and non-electrical measurements. Electrical measurements, electronic measurements, and non-electrical measurements. So if you see the content step by step, so under the electrical measurements, what we are going to have, we are going to have the measuring instruments first of all. Under the measuring instruments, we are going to discuss PMMC, moving iron, dynamometer, next energy meter, dynamometer. Next comes the energy meter, and very rarely we are going to get of the CTPT, current transfer and potential transfer. Next comes topic error analysis. Next comes bridges. So these are the fundamental topics. These are the fundamental topics. Okay, so under the bridges we're having the DC bridges and AC bridges also. और कोई लाइव में है तो मुझे बताओ यार, if anybody is in the live. वनक्कम वनक्कम. Yes. चलो, under the electronic measurements we are going to have three topics, majorly cathode ray oscilloscope, digital voltmeter, and Q meter. नॉन इलेक्ट्रिकल मेजरमेंट्स में हमको ट्रांसड्यूसर आएगा. सो नॉन इलेक्ट्रिकल मेजरमेंट्स हमको ट्रांसड्यूसर्स आएगा, बट दिस पर्टिकुलर टॉपिक इज नॉट रिलेटेड टू गेट. This is IES related, but in BARC we can expect this. Transducers related we can expect the questions. See, under the transducers what we are going to have? We are going to have a list of transducers like strain gauge, RTD, thermistor, thermocouple, next flow measurement, flow and pressure. Okay, so these all are the topics. Okay, transducers. So this is actually in the part of gate, it is there. In the part of IES also it is there. These topics are present for the gate syllabus and also for IES syllabus. This part is also present for gate syllabus and IES syllabus. But this part is only for IES syllabus. It's not in the gate examination. Okay, my dear. So this is the gate. IES is there. Gate is there. IES is there. Gate no. IES is there. Okay, done. Chalo. Now let us start the questions one by one. So try to answer this question. Chalo. What is the question? Two resistors with nominal resistance values R1 and R2 have additive uncertainties of del R1 and del R2 respectively. When the resistors are connected in parallel, the standard deviation of the error, the equivalent resistance R is dash. Okay, chalo. So if you see now, actually there is one concept solution. I will go with the solution. Okay, so listen the carefully solution. Suppose Z is a function of x comma y. Z is a function of x comma y. So uncertainty in x is wx. So that is uncertainty x is equal to wx. Uncertainty means the type of error, just like mean, deviation, average deviation, standard deviation. Uncertainty x is wx. Next, uncertainty in y is wy. Then uncertainty in z is wz. So then wz is equal to what? Then how to do it? So first we have to make whatever the function is given, that function z we have to differentiate with respect to x, dou z by dou x whole square, uncertainty in x whole square plus next dou z by dou y whole square into uncertainty in y square. So that is a formula. Okay, so now in this question, what is given? Parallel resistors are given. So R is a function of R1 and R2. R parallel will be what? R1 R2 by R1 plus R2. So how it will be now? Uncertainty in R will be equal to, so this parallel resistance whatever is there, dou R by dou R1 whole square, uncertainty R1, that is delta R1 whole square, plus dou R by dou R2 whole square, uncertainty in R2 delta 2 whole square. Yes, ऑप्शन ये. यस, आयांक कोजी शिवम गुप्ता. सिलेबस कुछ नहीं है बेटा, गेट का सिलेबस लेंगे फर्स्ट ऑफ ऑल. सो इसका आंसर क्या होगा? इसका आंसर ऑप्शन ये होगा. दिस क्वेश्चन वाज एक्चुअली फ्रॉम अ गेट सीरीज क्वेश्चन. सो बार के लिए हम स्टैंडर्ड गेट सिलेबस देखते हैं. यस यस यस, आई हैव टॉट दिस इन अ क्रैश कोर्स आल्सो. सो नाउ if you want to know exclusively under the measurements, I want to give non-electrical measurements also today. Okay, answer this question. Suppose the resistors R1 and R2 are connected in parallel to give an equivalent resistance R. If resistors R and R2 have tolerance of 1% each, the equivalent resistance R of resistance R1 is 300 ohms. So this is 300 ohms. This is 300 ohms and this is 200 ohms. So what is given here? This is 300 ohms and this 200 ohms will have a tolerance of dash. So how to do this question? Uncertainty is given over there. So first of all, we have to find out this uncertainty like this. So if you want to know parallel resistors, I can go for like this method, because they are not uncertainty, they are given tolerances. So what I will do is 1 by R is equal to 1 by R1 plus 1 by R2. Okay, so now if I am doing partial differentiation of this, minus 1 by R square, this is minus 1 by R1 square, dou R1 by dou R, and this is minus 1 by R2 square, dou R2 by dou R. Okay, and this I will take as 1 by R into R. This is 1 by R1 dou R1 by dou R plus 1 by R2 into R2 dou R2 by dou R. So now R1 comes here. So if I am taking this dou R here, this dou R by R here, and one R comes here, R by R1 dou R1 by R1 plus R comes here, this is R by R2 dou R2 by R2. Am I right? See what I have done? R square na, 1 R. So 1 R comes here, so R comes here, so R by R1 dou R1 by R, dou R1 by R1, dou R comes here. So dou R I have taken to the LHS side. Okay, dou R I have taken to LHS side. Dou R by R is equal to R by R1 dou R1 by R, dou R1 by R1. Next R comes here, R by R2 dou R2 by R2 aa gaya. Okay, so now if I go for further, what I can take here, this is dou R by R is equal to what is mentioned here, R by R1. So this is R by R1 dou R1 by R1 plus R by R2 dou R2 by R2 हो जाएगा. So if you multiply, see here why we are not adding, that means if you take the R value, this is R1 R2 by R1 plus R2, right? You are having uncertainty in R1, you are having uncertainty in R2. But practically speaking, you don't have the uncertainty of R1 plus R2. R1 plus R2 are, they're not dependent. R1 is not dependent R2, R2 is not dependent R1. समझ में आपको? That is the point. So we have the uncertainty in R1 and uncertainty in R2, but we don't have the uncertainty in R1 plus R2, that summation. So uncertainty in R1 plus R2 is a different parameter, right? So we cannot add the uncertainties. Del R1 plus del R2 can be added, but this is product and this is summation. We cannot do like this. That's why for parallel combination, better to go for the partial differentiation. Okay, so that is the scenario. So now if I'm multiplying here, though R by R into 100 is equal to R by R1, though R1 by R1 into 100 plus R by R2 into though R2 by R2 into 100. Okay, na? So this is, do you understand now? Is it clear? Percentage in R is equal to R by R1, percentage in R1 plus R by R2, percentage in R2. So these are the points. So what is R now? If you see the R is a product of these two resistors, 300 into 200 divided by 300 plus 200. So it becomes as 120 ohms. 120 ohms. So this is 120 by R1. What is the R1? 300. And percentage in R1. Percentage in R1 is 1%. Plus this is R by R2, that is 200. 120 by 200. 1%. Okay, Ashraf Hussain. Yeah, what is the answer for this? So now if I'm taking this, kitna aa raha hai answer? कैलसी यूज करो भाई, कितना आ रहा है आंसर? $17 members watching. So कितना आ रहा है आंसर? So we can take 120 divided by 300 plus 120 divided by 200. So 1% ही आ रहा है ना? So answer is 1%. Option B is the right answer. That is the methodology how to do it. 1% is the right answer. The other way also there. The other way is 1% of each resistor you take and add it and you can get the answer. That is the lengthiest method. 1% of each means what happens? 303 ohms hoga. This is 202 ohms hoga. So you take 303, 202 and you do it. You'll get R equivalent. Okay. So like that also we can do it. See, for example, method 2 also I'm telling. But sometimes this method 2 is lengthy. But better, some people are confused with differentiation method. They can go for this. If you go for the method 2, what is the method 2 here? That is 300 ohms 1%. So R1 is 300 ohms 1%. So R1 is 300 ohms plus or minus 1%. 1% means how much? That will be plus or minus 1 by 100 into 3. So that will be 3. Okay, next. R2 is equal to 200 ohms plus or minus 1%. 200 plus or minus. So it will be either 297 or 303. This will be either 198 or 202. So now what R equivalent I will take as R1 R2 divided by R1 plus R2. So I will take these two values. Suppose if I am taking 303 and 202. So this is the 303 and R2 is 202 divided by 303 plus 202. This is 505. 303 into 202, that is 61 2006 divided by 505. It is coming as 121.2. So if you see what was 121.2 is coming now. So actually what should be the R value? If I am taking only the values of, this is a measurement value. So what is the true value? True value will be 300 into 200 divided by 300 plus 200. So that could become as 120 ohms. So the true value is 120 ohms. So if you take the percentage error here, percentage error here is measurement value minus true value divided by true value into 100. So the measurement value is given as 121.2, true value is given as 120, and this is 120 into 100. So answer कितना आएगा? Exactly 1%. Are understanding? This is also one method. Yes, you can get some IIT for MTech, no issue. So this is 1%, my dear. So the right answer goes to 1%. So 1% is the right answer. In both the methods I have given you the clarity. All of you clear? Yeah, chal. Now let us go for one more question. Yeah, try to answer this question. This question. This question is from the moving iron measuring instruments. Try to answer. A moving coil instrument having a resistance of 10 ohms gives a full scale deflection. So try to answer this question. But after I am giving 1 minute of time. Chalo. A moving coil instrument having a resistance of 10 ohms. So if you see, This is having a resistance of 10 ohms, gives a full scale deflection of the current 10 milliamperes. So this is 10 milliamperes and this is a resistance. So if you see now, so this is having 10 milliamperes, this is Im and this is Rm. So now if you see this Im as 10 milliamperes and Rm as what? 10 ohms. So now if I take this Vm, okay, so what is a Vm here, my dear? So Vm is equal to Im into Rm. So that Im is equal to 10 milliamperes, that is 10 into 10 power minus 3, and Rm is equal to 10 ohms, so that becomes as 100 millivolts. What should be the value of series resistance to be added? What should be the value of series resistance to be added? These are series resistance to be added. What should be the value of series resistance to be added so that this voltage can be extended to the range of 100 volts? So what is the RSC is asking? So you can answer this question directly. Formula RSC is equal to Rm into M minus 1. Series mein aayega M minus 1. So that further can be written as Rm into capital V by small Vm minus 1. So meter resistance is given as 10 ohms. Capital V is given as 100 and Vm is coming as 100 millivolts. 100 milli minus 1. So 100 and cancel. Milli upar gaya to 1000. 1000 minus 1, 999. So answer will be 9990 ohms. So the right answer is option B hoga. Very good. Next, answer this question. Chalo. An ammeter has a current. An ammeter has a current range of 0 to 5 amperes. Internal resistance is 0.2 ohms. In order to change the range to 0, so it's ammeter question. So we can go for like this. So we can go this. Parallelly, we can take shunt resistance like this. This is RSH, this is RM, this is IM, this is ISH, this is I. So here if I am taking the RSH value, RM by M minus 1, that means RM by I by IM minus 1. So ammeter has a current range of 0 to 5 amperes. So this is 5 amperes. Its internal resistance is given here as 0.2 ohms. Okay, in order to change its resistance 0 to 25 amperes. So this is 25 amperes. Wants to range extension to 25 amperes. So the meter resistance is 0.2 divided by capital I is equal to 25 and Im is the meter, that is 5 minus 1. So 0.2 divided by 5, 25 by 5 minus 1, 4. So 0.2 by 4 कितना आएगा? 0.2 by 4 means कैल्सी यूज करके कितना? 0.5 0.05, yes, 0.2 divided by 4, it's coming as 0.05 ohms in parallel. So it's a shunt resistance, that is a parallel resistance, so I can take the value as 0.05 ohms in parallel with the meter. So let us go for the next question. Answer this question, my dear. Answer this question. Chalo. An average reading digital multimeter reads 10 volts with a triangular wave symmetric about the time axis, the same input RMS reading. So we are, say it's a triangular wave, right? So it's a triangular wave. It will go like this. Average reading digital multimeter reads 10 volts when fed with a triangular wave. So what is the same input of RMS reading is asking. So what can be the answer? So this is given as VRMS is equal to Vm by root 3 for triangular wave. So this is the 10 volts average value is given as 10 volts. So the answer will be 10 by root 3. Option B is the right answer. 10 by root 3. Huh? Any doubt? Oh. Correct. Actually, this is, he has mentioned as symmetrical time axis. I mentioned, right? It is given as symmetrical about the time axis. We have forgotten that. It's given as symmetrical time axis. So if you see the symmetrical time axis means it is, the axis will be like this. So if this is a triangular waveform, symmetrical time axis means it is not exactly here like this. Okay, so if it is going like this, so this is 10 and this is 10. So V maximum, V average is 10. So Vrms is equal to V maximum by root 3. So that is, this is 10 plus 10, that will be 20. 20 by root 3. Yes, option A is the right answer. Correct, correct, correct. Option A is the right answer. जो आपने बताया वो correct है. 20 by root 3. Yes, yes, correct, correct, correct. Yes. Chalo. Now let us go for the next question. Answer this question. A balanced Wheatstone bridge ABCD has the following resistances: 1 kb plus or minus 2.1%, 100 ohms plus or minus 0.5%, RCD is unknown resistance, 300 ohms plus or minus 0.4%. The value of RCD and its accuracy is dash. Okay, so this is also very interesting, simple question. So he has given this as let us take this as A, this as B, this as C, this as D, this as plus, this as minus. A balanced Wheatstone ABC has the following ohm resistance. This is 1 kilo ohm, 1 kilo ohm plus or minus 2.1%. This is BC, this is 100 ohms plus or minus 0.5%. Next, this is R, CD, this is unknown. Next, this is DA, this is 300 kilo ohms plus or minus 0.4%. Okay, so what is asking? CD is asking. So RCD into RAB is equal to Astuna RBC into RAD. Okay, so RCD is equal to RBC into RAD whole divided by RAB. So RBC is equal to 100 into RAD is equal to, I think this is wrong, I think so. It's a printing mistake, I think so. Okay. So if you see this, I think this is a printing mistake. 3000 ohms should come means 1K should be 300 ohms, I think. So if you take 300 ohms, so 100 into 300, the whole divided by RAB, that is 1000. So that will become as 30 ohms. Okay, so if you see the percentage will be added 2.1% plus 0.5% plus 0.4%. So 0.9 plus 2.1, 2.1 plus 0.9, 3%. So 3% of 30, 30 into 3 by 100, 90 by 100, 9 by 10, 0.9 ohms. So option B is the right answer. Am I right? Option B is the right answer. एक बार check करो को बताया. Correct only, na? $100K should be there in question for RBC. 100K. Now it is coming now. If I am taking 300 ohms, is it matching or not? 300 into 100 by 1000. So 30 ohms. 30 ohms plus or minus 3%. 30 into 3 by 100. 90 by 100. 9 by 10. 0.9 ohms. So option B हो रहा है. So I have taken this as 300K now. 300 ohms. Okay. This is 300 ohms. Please take this is 300 ohms plus or minus 0.5%. Now it will be matching. This is a product of quantities. For the product of quantities, you can go for the percentage error. So this is a percentage error like this. 3% is matching. So 30 ohms plus or minus 3%. 30 plus or minus 3%. So 3 by 100. 3 by 100 if 30. 90 by 100. So 0.9. Okay. Chalo. Answer this question. The bridge method commonly used for mutual inductance. So if you see this particular sharing bridge is for capacitance measurement. DSRT bridge is also for capacitance measurement. Wien's bridge is for frequency measurement. And Heavenson-Campbellson bridge is the mutual inductance. On bridges we'll get simple questions sometimes, and sometimes some complicated questions also possible. Okay. Yeah. Okay. Try to answer this question. The question is on 2 wattmeter method. So in power measurement on 2 wattmeter we can expect good number of questions. Two wattmeter question. So on 2 wattmeter, yes. Any PSU for 40 marks? That depends upon your reservation. 2 wattmeter के लिए आपके पास question है. So we can go for like this. Tan phi, that is a formula for 2 wattmeter method. We have a formula, right? So we can use that formula. Tan phi Okay, so from the phi we can find out the power factor also. Tan phi is equal to root 3 into W1 minus W2 divided by W1 plus W2. So these are the wattmeter readings. जरूर आपको ये पर्टिकुलर फार्मूला पर कोई भी एग्जाम में एक सवाल आने की चांसेस है। अगर आप गेट एग्जाम लिख रहे हो और नॉन गेट एग्जाम लिख रहे हो, बार्क एग्जाम लिख रहे हो, कोई भी पीजी सेट लिख रहे हो, कोई यूनिवर्सिटी का कॉमन एंट्रेंस टेस्ट लिख रहे हो, हमको गेट में जो पावर मेजरमेंट टॉपिक है ना, पावर मेजरमेंट टॉपिक है, 1 मिनट के अंदर क्वेश्चन सॉल्व करने के लिए हमको जरूर ये पावर फैक्टर का फार्मूला के ऊपर क्वेश्चन आने ही आने हैं। सो वही क्वेश्चन आ सकता है इधर। So tan phi is equal to root 3 double 1 minus W2 by double 1 plus W2. Check it. What is mentioned? 2 wattmeter method is used for measurement of power in a balanced three-phase load supplied from a balanced three-phase system. The one of the wattmeter reads half of the other. See, for example, let us take W2 is equal to half of the W1. Let us take half of the other. Then what happens? The power factor is asking. So if I am substituting this is W1 and W2 is equal to half of the W1 whole divided by W1 plus half of the W1. Okay, so that becomes as this is 1 by 2 W1 divided by 3 by 2 W1. Okay, so now if I am going for this tan phi, I can take it as like this. Tan phi is equal to root 3 into this is 1 by 2 into 2 by 3. So now this 2 gets cancelled. So we are going to get root 3 into 1 by 3, that is 1 by root 3. So phi is equal to 30 degrees. Tan 30 is equal to 1 by root 3. Got it? EWS category means there are chances are there, Shivam Gupta ji, आपको आने के chances है. So question asking is power factor. So power factor is equal to cos phi, that is cos 30 root 3 by 2, that means 0.8666 is the answer. So answer D is the right option. Option D is the right answer. Okay, so आप समझने की कोशिश करो, ये फार्मूला के ऊपर जरूर आपको क्वेश्चंस आने की चांसेस है। और एक क्वेश्चन भी आ गया, देखो ये क्वेश्चन आंसर करने की कोशिश करो। जितने लोग बाबा एटॉमिक रिसर्च सेंटर के एग्जाम के लिए प्लान कर रहे हो, ये क्वेश्चन से जरूर आपको क्वेश्चंस आने ही आना है। सो प्लीज फोकस ऑन दिस क्वेश्चंस। नाउ सी दिस क्वेश्चन, ट्राई टू आंसर दिस क्वेश्चन। चलो, power consumed by a balanced 3-phase 3-wire load measured by 2 wattmeter method. The first wattmeter reads twice that of the second. So this is just again same model question, but see the difference. The question asked here is in terms of tan phi is equal to root 3 into W1 minus W2 divided by W1 plus W2. So first wattmeter reads the twice of the second. That means W1 is equal to 2W2. Okay. So now if I am getting this root 3, if I write, so this is 2W2 minus W2 the whole divided by 2W2 plus W2. Am I right? First wattmeter reads is twice of the other. So क्या होगा उसको? root 3 into this is W2 and this is 3W2. W gets cancelled. So again 1 by root 3 आएगा. 1 by root 3 आएगा. So phi becomes as how much? Tan phi is equal to 1 by root 3. That means phi is equal to 30 degrees. But question here asking is the angle in radians. So 30 degrees in radians को बोल सकते 30 degrees in radians. Yes, Charan Pratnam, very good. 30 degrees in radians. So we know that 360 degrees is equal to 2 pi radians. So 1 degree is equal to pi by 180 radians. So 30 degrees is equal to pi by 6 radians. So the right answer for this particular question goes as pi by 6 radians. So जितने लोग लाइव में हैं मुझे एक बार वॉइस कंफर्मेशन कर दीजिए बेटा, ऑडियो वीडियो सब कुछ क्लियर है नहीं? जरूर मैं बोल सकता हूं ये पर्टिकुलर पीपीटी से मैं जो क्वेश्चंस आपको बोल रहा हूं इससे जरूर आपको 2 और 3 क्वेश्चंस रिपीट हो जाएगा, क्योंकि एवरी ईयर बार का पेपर में ऐसे हो रहा है। बार का रिजल्ट आने के बाद आप देख सकते हैं, बार का पेपर आने के बाद देख सकते हैं। Now let us see one question on the CRO, cathode ray oscilloscope. So if you see this question on cathode ray oscilloscope, try to answer this question. Topics are related to electronic measurements. चलो, this question, a stationary closed Lissajous pattern on oscilloscope has 3 horizontal tangencies and 2 vertical tangencies. So how to understand this question for a CRO? Frequency applied on the plates, frequency applied on the vertical plates to the frequency applied to the horizontal plates is given as number of horizontal tangencies. Horizontal, I'm writing fully. So this is a number of horizontal tangencies, the whole divided by number of vertical tangencies. So on this particular simple formula, measurements is such a subject, जितने लोग इलेक्ट्रिकल स्टूडेंट्स हो इधर, जितने लोग इंस्ट्रूमेंटेशन बच्चे हो, मैं आपको ये हिंट देना चाहता हूं, आपका जो भी सब्जेक्ट्स है, कोर सब्जेक्ट्स लाइक पावर इलेक्ट्रॉनिक्स, पावर सिस्टम्स, नेटवर्क थ्योरी, एनालॉग इलेक्ट्रॉनिक्स, डिजिटल इलेक्ट्रॉनिक्स, इसमें ज्यादा पढ़ना है, आपको ज्यादा कोशिश करना है, बहुत सारे टॉपिक्स रहता है। लेकिन मेजरमेंट्स ऐसा सब्जेक्ट है 40 और 30 इंस्ट्रूमेंट्स रहेगा, उसके ऊपर कुछ फार्मूलास रहेगा, वही फार्मूलास पर हमको क्वेश्चंस हमेशा आ सकता है। सो अगर मेरा क्लासेस आप रेगुलरली फॉलो करो तो मेरा फार्मूलास जो भी मैं नोट्स दे रहे, whatever the formulas I am giving on this board, if you maintain those formulas as a running notes and keep as a clip, keep as a short notes in your study room, and whenever you wake up or whenever you are before going to sleep, just to have a glimpse of those formulas, and automatically you will get a question related to that particular formula. Because with my experience I am telling, ये फार्मूला को कैसे याद रखना, देखो fy by fx, दिस y एक्सिस, इसका ऑपोजिट होना है न्यूमरेटर में इधर हॉरिजॉन्टल, ये x एक्सिस बोलते हो x एक्सिस बोलते हॉरिजॉन्टल, लेकिन इसका ऑपोजिट इधर होना है वर्टिकल, दैट्स इट, सिंपल। इधर y बोलो तो इधर ऑपोजिट होना है, इधर x बोलो तो इधर ऑपोजिट होना। सो नाउ इफ यू गो फॉर दिस, नंबर ऑफ हॉरिजॉन्टल टेंजेंस कितना है, देखो स्टेशनरी क्लोज 3 हॉरिजॉन्टल टेंजेंसीज, this is how many horizontal tangents, this is 3 horizontal tangencies divided by vertical tangencies 2, so that becomes as 1.5. so fy will become as 1.5 into fx. लेकिन क्वेश्चन क्या पूछ रहे हैं, the frequency of the vertical input is asking. So if it is given as fx is given as how much, 3 kilohertz. Horizontal input with a frequency of 3 kilohertz. So if you apply that 1.5 into 3 kilohertz, so 1.5 to 3 kilohertz, that will become as 4.5 kilohertz. So the right answer for this particular question here is 4.5 kilohertz. Option D is right answer. Miss mat karna. Very good. Very good. जितने लोग लाइव में है, everybody is giving the right answer. Option D is the right answer बेटा. ऑप्शन बी नहीं है, ऑप्शन डी है, क्योंकि Fi इज इक्वल टू 1.5 इंटू एफ एक्स का फ्रीक्वेंसी हॉरिजॉन्टल का फ्रीक्वेंसी है 3 किलोहर्ट्ज. सो आंसर इज 4.5. दिस क्वेश्चंस लिसेजस पैटर्न्स बोलते हैं. कैथोड रे ऑसिलोस्कोप यूज करने के समय अगर दो सिग्नल्स को फ्रीक्वेंसी वेरिएशन है, इसके अनुसार आपको ये डिफरेंस आ जाएगा. ओके, चलो बेटा, लेट अस मूव फॉर सम अदर क्वेश्चन. आंसर दिस क्वेश्चन. So here see question. The current is measured in electrical circuit as 5 amperes. So this current is 5 amperes. The current is given as 5 amperes with accuracy of plus or minus 0.5%. So this is 5 amperes plus or minus 0.5%. This current is flowing through a resistor. R is equal to again 5 ohms. This is 5 amperes. This is 5 ohms plus or minus 0.25%. The power dissipated in the resistor will be dash. So power is equal to formula I square R. So he's asking the power with percentage error. So simple question. Power is equal to I square R. That means 5 into 5 into R is equal to 5. So 5 5 is 25, 5 is 125. That's fine. 125 watts. And what about the percentage error? The percentage error in power will be equal to percentage error in 2 times of I plus percentage error in I plus percentage error in R. So percentage error in I is equal to 0.5% here, and this is 0.5% here, and this is 0.25% here. So that becomes as 0.5 plus 0.5, 1.25%. So the right answer for this question here is, so the total power will be 125 plus or minus 1.25 percentage hoga. So the right answer is 1.25 percentage hoga. Okay, so that's it. These are the good questions, quality questions. Miss mat karna questions ko. Answer this question. For a certain dynamometer ammeter, the mutual inductance M varies with deflection. So M is given as how much? This is given as minus 12 cos of theta plus 10 degrees. Find the deflecting torque produced by a direct current of 25 milliamperes. Current is equal to 25 milliamperes. Corresponding to a deflection of 50 degrees. Theta is given as 50 degrees. This question is related to dynamometer, my dear दोस्तों. डायनामोमीटर के लिए फॉर्मूला है I square dm by d theta. डिफ्लेक्शन डर का फॉर्मूला ए है I square dm by d theta. So first of all, let me calculate the dm by d theta. So dm by d theta, फॉर्मूला बेस्ड क्वेश्चन से आएगा, क्योंकि गेट में है तो आपको कुछ कॉम्प्लेक्सिटी होता है, लेकिन गेट नॉन गेट एग्जाम लेकर तो मेजरमेंट्स में डायरेक्ट फॉर्मूला बेस्ड क्वेश्चन आएगा. सो माइनस 12, सो कास के डेरिवेटिव करो तो माइनस कास थीटा आ गया बेटा. कास थीटा बोलो तो उसको डेरिवेटिव करना है, माइनस साइन थीटा आएगा. सो दिस इज माइनस साइन ऑफ थीटा प्लस 10 होगा. सो माइनस इंटू माइनस प्लस, सो 12 साइन ऑफ थीटा प्लस 10 होगा. ओके, सो नाउ एट ए डिफ्लेक्शन ऑफ हाउ मच? 50 degrees. So at 50 degrees, dm by d theta at theta is equal to 50 degrees. So now I will write this as plus 12 sine of 50 plus 10, that is 60. Sine 60 means root 3 by 2. So now I will write the formula. I square is 25 milliamperes. So 25 into 10 power minus 3, 25 into 10 power minus 3, and dm by d theta is equal to 12. And this is sine 50 plus 60, sine 60. Sine 60 is equal to root 3 by 2. Am I right? So now if you see 25 25 is 225. 25 25 is 225. So 225 into 12 divided by 2 into root 3 into 10 power. अच्छा कुछ गलत आ रहा है? अच्छा 25 25 625 ना, सॉरी. 25 into 25 625, 625 into 12 into root 3 divided by 2 into 10 power minus 6 is coming as 6.5. It's millihenry na, so this is 10 power minus 3 even. So 6.5 microhenry per radian आएगा. So right answer, sorry, micronewton meter, sorry, this is torque na, so torque formula micronewton meter. Very good question, formula based question. Option A is right answer. Yes, very good, very good. Some of the students are answering very well. Chalo. So now let us go for the formulas. So let me explain some formulas here. हमेशा मैं बच्चों को ये formulas के लिए लिस्ट देता हूँ. So if you see this formulas के लिए मैं पास लिस्ट देता हूँ, PMMC, deflection torque, controlling torque ऐसे. So if I am taking the measuring instrument here, is a measuring instrument. So if you take the deflection torque and this is a controlling torque. So for measuring instrument, if I am taking the PMMC, for PMMC the deflection torque formula is bina, controlling torque formula is Kc theta. Next, moving iron formula 1 by 2 I square dl by d theta. Sorry, I have to write the instrument name here. So this is a moving iron. Famous instruments, majorly these are the instruments. 1 by 2 I square dl by d theta. This is also Kc theta. Next comes the dynamometer. Next comes the electrostatic voltmeter. So next comes the dynamometer. These formulas अगर आपके पास याद रखे तो एग्जाम में जो भी क्वेश्चन से आप सॉल्व कर सकते हैं. So dynamometer के फॉर्मूला होगा I square dm by d theta, ये होगा kc theta. Simplification. Next comes the electrostatic voltmeter. इलेक्ट्रोस्टैटिक वोल्टमीटर के लिए फॉर्मूला होगा 1/2 v square dc by d theta, and this is kc theta. And if you go for energy meter, so this is also एक इंस्ट्रूमेंट है एनर्जी मीटर. एनर्जी मीटर में आपको केवल एक ही फॉर्मूला आएगा, नंबर ऑफ रिवॉल्यूशंस इज इक्वल टू k into E. K is the energy meter constant, E is the energy. So power is equal to energy per time, energy is equal to power into time. So that is VI cos phi to time. Okay बेटा, so this is the answer. So please remember, अगर आपके पास कोई शॉर्ट नोट्स है तो लिखो, ये शॉर्ट फॉर्मूलास आप याद रख के शॉर्ट फॉर्मूलास आप उधर स्टोर करो. मजा आ रहा है बेटा? Yes. After noting this, let us move for the next. Answer this question. The current in the two branches of circuit is equal to I is equal to I1 plus I2. Okay, this is I. Acha. Current in a circuit is given. Simple circuit is given like this. So this is one resistor, this is another resistor. This is I1, this is I2. So this is I. So I is equal to I1 plus I2. The values are given as 80 plus or minus 2 amperes. The value of I. So this will be 80 plus 120 and plus or minus the absolute errors 2 plus 1. So that is 200 plus or minus 3 amperes. 2 plus 1, 3 amperes. Why 3.33 is given? I don't understand. If the limit errors are given as standard deviation. Acha. Limits of errors are given as standard deviation. 3 amperes आ रहा है. What is कितना आ रहा है इसका आंसर? The current in the two branches of circuit is equal to I is equal to I1 plus I2. The value of I1 is 80 plus or minus 2 amperes and I2 120 plus or minus 1 ampere. 2 plus 1, 3 amperes. These are absolute errors. These are absolute errors. Suppose if I am going for uncertainty also, let me check. Suppose uncertainty, sigma in I, let us like standard deviation is mentioned. Na? So let me check that standard deviation. Suppose if I am taking dou I with respect to dou I1, that will become 1. Dou I with respect to dou I2, that also will become 1. So sigma of I, if I am going to get it, so this will be dou I by dou I1 whole square plus dou I by into uncertainty in I1, that is delta I1 whole square plus dou I by dou I2 whole square, uncertainty in I2 whole square. So this is dou I by dou I1, this is 1. Delta I1 is 2 amperes, that is 2 square plus this also 1. Dou I2, that is given as 1 ampere. So now I am going to get this answer as 2 square 4 plus 1 root 5. Root 5 is ungiven. So we have to go for this. Perfect answer is this. Yes. Square root of 5, I check 2.23. So the right answer is 2.23 amperes. Very good. Perfect. Why? Because standard deviation is the most accurate method comparatively. Absolute errors, these are not absolute errors. Actually, these are the standard deviations. I have made a mistake here. This should be written as sigma I1 and this should be written as sigma I2. Okay, like this. Got it? So let's go for the next question. Answer this question. इसका आंसर कितना होगा? A moving iron ammeter shows a full scale deflection of 120 degrees. So this shows a full scale deflection of 120 degrees. Due to torque of 300 micronewton meters, deflection torque of 300 micronewton meter, which was produced by a current of 20 amperes. This current is equal to 20 amperes. The rate of change of self-inductance is asking. So directly I can write TD. So moving iron की formula 1/2 I square dl by d theta होगा. So this is 300 into 10 power minus 6 is given. 1/2 I square is 20 amperes. This is 20 amperes. And is asking the dl by d theta. The rate of change of self-inductance is asking. So deflection torque is microhenry per radian. So what is the answer here? This is 300 into 10 power minus 6, that is equal to 1/2 into 400. This is dl by d theta. So 600 into 10 power minus 6 divided by 400 is equal to dl by d theta. So these two gets cuts. 1.5 microhenry per radian. That is answer. Option A is the right answer for this particular question. Okay. Yes. Done. Chalo. You answer this question. A wire potentiometer length 15 meters and resistance is 1.6 ohms per meter. Balance a standard cell voltage of 1.36 volts at a length of 12 meters 75 centimeters. If the voltage of the battery supplying the current through the potentiometer is 2.5 volts, then the value of the series resistance connected to the potentiometer is this. Very good question actually. अगर आप सोच के बताए तो अच्छा क्वेश्चन है. This question is on potentiometer. चलो, see this. A wire potentiometer. So how to understand this question? This is a wire potentiometer. So this is a wire potentiometer of length 15 meters. This length is 15 meters. So 15 meters. So 1 meter ki 1.6 ohms means 15 meters ki how much? 15 into 1.6. So 24 ohms. So this is 24 ohms. Balances a standard cell. So this balances a standard cell at a length of 12 meters 0.75 centimeters. You have to understand this very clearly. So here if I am keeping a balanced cell, it balances exactly at a length of 12.75 centimeters. If the voltage of the battery is supplying the current, so there is a battery here, series resistor भी है, so this is the working current, this is a plus minus. So here comes the series resistor, that is the RH. See here, a wire potentiometer of length 15 meters. This total length was 15 meters. If you see this total length is 15 meters. And resistance of 1.6 ohm per meter. Okay, balanced standard cell is given. So 12.75 centimeters దగ్గర this galvanometer reading is equal to 0. So now what is the question is asking? He has given this battery supplying this voltage, he has given as 2.5 volts. This has given as 2.5 volts. And the value of the series resistance connected here. So this value is asking of the potentiometer. So this value is asking, my dear. So to find it out, first of all, I have to find out this battery voltage is given as how much? If the voltage of the standard cell is 1.36 volts, this standard cell is 1.36 volts. That means this particular potential drop, its balance means this potential drop and this potential drop must be same. Okay, so this potential drop and this potential drop must be same means this 1.36 volts must be equal to what? This resistance and this working current. Current cannot pass through here, the current passes here. So 12.5 centimeters. So here it is given as 1.65, 12.75 meters. Sorry, this is 12.75 meters. 12.75 meters. So 1.6 ohms per meter. So 1 meter corresponds to, so we can write like this. 1 meter corresponds to 1.6 ohms. 15 meters corresponds to how much? 15 meters. 15 into 1.6, that is 24 ohms. That's fine. Now it is 12.75 meters. 12.75 meters corresponds to how much? 12.75 into 1.6, that is 20.4 ohms. Okay, so now this is 20.4 ohms. So now what happens? This 1.36 volts is equal to this resistance 20.4 and the current. That current is nothing but working current. Okay, so that will become how much? 1.36 divided by answer. That working current will be coming as 0.066 7 amperes. So now he is telling this total loop, if you take this total loop, if you take 2.5 is equal to the working current into this RH resistance plus this total resistance. This total resistance is 24 ohms. This is resistance of the wire. Okay, so this is 2.5. This is IW. RH is we don't know. IW we know. IW कितना था? 0.0667 amperes. RH is rheostat current, that is we don't know, we have to find it out. And the wire resistance for the 15 meters is 24 ohms. Very beautiful question. So 2.5 divided by 0.0667 minus 24, 13.4 it is coming. Anything mistake we have done, my dear? Any mistake we have done? 3.75 ohms. क्या मिस्टेक हो गई यार? मुझे 13.48 आ रहा है यार. 13.48 is coming. Answers are not matching here. 13.48 plus 24 into 0.0667. So I think answers are not matching here. So please take the answer. RH is equal to 13.4. 13.4 ohms होगी. So answers not matching. एक बार मुझे confirmation कर दीजिए यार these answers. No रे, no. Resistance of the wire is अच्छा 15 into 1.6. कैसा? RW is 20.4 कैसा आ गया विष्णुवर्धन जी? RW is 20.4 ohms. 24 is correct ना? Options wrong होगा. Options wrong. 20 point for 12.75 meters it is 20.4. The balance for this ना 1.36 की balance 12.75 लेना है. So 12.75 की 20.4, 20.4, the same working current will come here ना. No current will travel here. The current will be zero here. This current will be zero. So the galvanometer current, whatever is there, the loop will be like this. Options wrong होगा शायद. Yes. Yes. Methodology is correct. 20.4 is for 12.75 meters. That is not the length of the wire. Length of the wire is 15 meters. Length of the wire is 15 meters. Same, sir. Yes. Yes, correct. Length of the wire is 15 meters here. The potentiometer length is 15 meters. ఇది 12.75 కి was balance వచ్చింది. Answer this question. Same model. आंसर देखो भैया, a single slide wire is used, again the same topic, single slide wire. Used in a circuit, the voltage drop across a standard resistance of 1.6 ohm balances 75 centimeters. Then the magnitude of the current if the standard cell having a EMT of 1.75 volts is balanced at 54 centimeters. A single slide wire is used for the measurement of a current in a circuit. The voltage drop across a standard resistance of 1.6 ohms. So let us take a standard cell here. Okay, so this is at 75 centimeters, it is balanced, but resistance value is not given. A single slide wire is used for the measurement of a current in a circuit. The voltage drop across a standard resistance of 1.6 ohms. The voltage drop across a standard resistance of 1.6 ohms. So this is 1.6 ohms is balanced at 7.75 centimeters. Then the magnitude of the current, the standard cell having EMF of 1.75 volts, balanced at 54 centimeters is dash. So try to understand this question. So let me take here, this is our battery. Rheostat current is not mentioned, so we can take this. This is a working current. "75 centimeters corresponds to 1.6 ohms. Then 54 centimeters corresponds to how much? We can make a calculation for it. Then we can calculate the current. Then the magnitude of the current if the standard cell having EMF 1.75 volts. So 75 centimeters corresponds to 1.6 ohms means 54 centimeters corresponds to what? 1.6 divided by 75 into 54, that is 1.152 ohms. 1.152 ohms. Okay, so it is balanced, the EMF is balanced as 1.152 into current into resistance, sorry, current. So that is a working current. So that is 1.75 volts. This is 1.152 into, this is working, 1.75 divided by answer. So I'm getting as 1.5. This is a working current, 1.5. Option A. Got it? Very good question. आपको जस्ट कॉमन सेंस यूज करना है, बैलेंस मेथड का कॉमन सेंस यूज करके करना है. Answer this question. Which of the following methods is used for the measurement of low resistance? very famous question, बहुत सारा क्वेश्चन आ चुका है. अरे यार ये YouTube का सेशन है रे. YouTube का सेशन का हमको लिमिटेड टाइम रहता है ना, एक घंटा क्रॉस हो गया ऑलरेडी, 1.5 आवर का सेशन चल रहा है. लॉस ऑफ चार्ज मेथड इज फॉर हाई रेसिस्टेंस मेजरमेंट. Kelvin's double bridge is for low resistance measurement. This is less than 1 ohm. This is more than 100 kilo ohms. Next, Megger is also for high resistance. That is also more than 100 kilo ohms. Next, Ammeter voltmeter is for medium resistance, 1 ohm and less than 100 kilo ohms. Okay. So the right answer is Kelvin's double bridge. Kelvin's double bridge is the right answer. Anybody answer this question? Yes. Maximum velocity of the beam of electrons in a CRT having an anode voltage of, so this anode voltage he has given, so this voltage he has given as how much? Cathode ray tube, CRT means cathode ray tube, CR 2400 volts. Electrons leave the cathode with zero velocity. Charge of electron we know that is Q, that is 1.6 into 10 power minus 19 coulombs. And mass of electron also we know that mass is equal to 9.1 into 10 power minus 31. So what is asking? Is asking the velocity of electron. See here, potential energy is converted, physics concept. Potential energy is converted to kinetic energy. In the cathode ray tube, there is electron gun. That electron gun is going to be heated. From the heated, the electrons are coming out. So the potential energy is equal to Q into E, and kinetic energy is equal to half into mv square. So he is asking the velocity. So velocity physics concept, that is 2qE by m. So if you see this, square root of 2e the whole divided by m by q, mass to charge ratio. So that is a formula, physics concept. Potential energy of a battery, it is related as potential energy of a charge gun, electron gun, from where the electrons are emitting. So those electrons, the more is the voltage you are giving, the more faster they will come out. The acceleration velocity will be very, very high. The more is the potential energy, the more velocity, the most fastest electrons will come out. So q into E is equal to half mv square, velocity आपको substitute कर दिया. So here that is equal to square root of 2 into supplied voltage E is equal to 2400 volts divided by mass, that is 9.11 into 10 power minus 31 the whole divided by charge 1.6 into 10 power minus 19. So please simplify this. 9.11 into 10 power minus 31 the whole divided by 1.6 into 10 power 19, 4800 divided by answer. How much you are getting? Please calculate it. कितना आ रहा है answer? Anybody is calculated here? Yes, Shubhakranti. Yes, what is the answer for this? 9 point mass to charge ratio na 9.11 by 1.602. How much is coming here? Calculation करके बताओ यार. 2400 volts ना. Okay, step by step करेंगे. So V is equal to square root of this is 4800. This is 9.11 into 10 power minus 31. This is 1.6 into 10 power minus 19. Yes. 2.905 10 power 7. Yes, exactly. Option C is the answer. Okay, done. So these are the standard questions. So enough for today. So please practice such type of questions. Okay, from the measurement subject you can practice electrical measurements and electronic measurements. Okay, some instrumentation questions can be also asked. For example, if you are preparing for the IS pattern, so from the IS you can take the transducer subject. From the transducers you can get certain questions. Okay, so if you are interested you can go for the transducer subject also. So from the transducers topic also you can take some questions. So those questions will give you some idea. Okay, so enough for today. I wish you all the best for the upcoming BARC examination. Thank you.